Hey everybody, we're going to continue into Chapter 8 now. Chapter 8 is all about polynomials. Polynomials are one of the most important parts of Algebra 1. Understanding polynomials, adding, subtracting, multiplying them. All of it will not only be on the keystones, but all of it is fundamental for moving on in any form of math. So today we can see that we have moved to a new anchor description. We're going to simplify expressions with polynomials. You can see the eligible content right here from the keystones, the Common Core state standards, and our goal for today, to classify, add, and subtract. My goal is to make my notes about 25 minutes. So let's see, I have 12:51, which will be perfect timing. I will try to end by 1:10 or 1:15. So let's go over some vocabulary. Monomials mean you have a single term, so like 18, or z, or -4x squared, or 2.5xy cubed. Now what I want you to see here is a lot of kids don't see this as a monomial, but unless let me give you an example of a binomial. So like you see this, that is not a monomial. Nope. But if there wasn't any adding, like if it was just like this, that would be a monomial. So it's one term, no adding, no subtraction. So each monomial has what we call a degree. The degree is the degree or the exponent on the variable. So I want to take a look at three quick examples. You can see that this variable has a degree of 1. That's why we say, because the exponent is 1 on the variable. So the degree would be 1. Let's take a look at b. Now b is a monomial because there is no adding and no subtracting. So I look at my variables and I add those exponents. That's how they get a degree of 5. So if a monomial has 2 variables, you add them and that's the degree. Now this one does not have a variable, does it? There's no x. So if there was an x, it would have a power of 0, because we know that that means it would kind of like go away and become a 1. So we would say that the degree is 0 because there's no variable. Now it's time to talk about what is a polynomial. Well, you should notice that instead of being a monomial, like that used to be the word monomial, we're going to have a polynomial. Well, poly means usually more than one or multiple. Like a polygon has more than one side. So what is the definition? So what I did is I went to the Keystone vocabulary. And here is what the Keystone vocabulary gives you. A polynomial. An algebraic polynomial. That's really big. Let me shrink that down. There you go. An algebraic polynomial is made up of a single monomial or the sum or difference of 2 or more polynomials. Here are 6 examples of polynomials. This one has 2 terms. See how it's separated by subtraction? This one has, let's count them, 1, 2, 3, 4 terms. This one has, see the addition sign? 1, 2 terms. This one has 1, 2, 3 terms. This one has 1, 2, 3 terms. And this one, they're separated by addition and subtraction, is 1, 2, 3 terms. So you can count the terms by counting like how many things are separated by addition or subtraction. So this one has 2, this one has 4, this one has 2, this one has 3, this one has 3, and this one has 3. And those numbers represent how many terms, how many monomials are in that polynomial. Now I need to tell you what standard form is. Standard form, you have to combine your like terms, which is something you've done before. The highest exponent needs to go first, and then it drops. So like whatever the highest exponent is, then the next highest exponent, then the next highest exponent, and so on and so forth. So I gave you 3 polynomials here. Let's take a look at the first one. Are there any like terms? Do any variables and exponents match? No, they do not. Is it in order? Does the exponent go greatest to least? Well, let's look. This exponent is 8, then 2, then 1, then none. Yes, this is in standard form. Look at the next one. Is this one in standard form? Well, I can't combine like terms, so I guess in that aspect it's okay. However, you see these exponents are out of order. This one should have been first. So no, this one is not in standard form. Let's look at the last one. So we need to see if there's any like terms. Oh, we have an issue here. See these two? These two should have been put together because their exponents match. So because they didn't get put together, that would not be in standard form. They would have to get put together first. So it does obey the rule that it goes highest to least, but it didn't like come out in like terms. The next part of the lesson is my job to teach you how to classify them. In other words, use like your big girl and your big boy words. So we're going to find out what the degree is, and then we're going to find out how many terms it has. And then once we find the degree, we're going to use one of these words. And once we find out how many terms it has, we're going to use one of these words. Words. I said worms. Let's take a look and classify by degree and number of terms. Now, it's very important that I keep that on my screen. I'm going to delete all those highlights because that was a little much. The first one. This is a special polynomial. It has a degree of 0 because it would be like x to the 0 power. It only has one term. So like you can see like it's only like one thing there. It's only a 6. So the name. So I look for a degree of 0. And then I look for one term. So this one would be a constant and monomial. That's the name. Number 2. So I see that there's only one item. There's no adding or subtracting. So I'm going to put that in my number of terms. And I see the exponent on x is a 1. So the exponent, the highest exponent I see is a 1. I should have color coded that. Wish I would have made that blue. Let me make that blue so you can see where I get that from. There you go. So I am going to call that, let's get rid of my old highlights. So I have a degree of 1, and I have a number of terms as 1. So that would be called a linear, and then switch monomial. All right, now for number 3. How many terms does it have? I actually like doing the terms first. It's separated by addition, so 1 and 2. I could probably go through and pick that now, couldn't I? Because it had 2 terms. See how I had 2 terms, 1, 2? That would be a binomial, so I guess I could already write that. And what's the highest exponent? Well, the highest exponent is whatever's on x, so there's a 1 there. So if I look at an exponent of 1, or a degree of 1, that would be linear. So it's weird. That last one was a linear monomial. This one's a linear binomial. On the next one, let's go ahead and count our terms. Separated by addition and subtraction, 1, 2, 3. I have 3 terms. I may as well write that word now. Let me erase my old markings. 3 terms is a trinomial. So I'm going to write that now. Trinomial. Now in blue, I'm going to find the highest degree, the highest exponent, which in this case is a 2. And I never marked the last one, apparently. Since the highest degree is a 2, I'm going to call that quadratic. Let's take a look at the next one. I can see I have 2 terms. 1, 2 terms. 2 terms is a binomial. Let's take a look at the highest exponent. The highest exponent is a 3. The degree is a 3. So I will call this a cubic binomial. We have one more. Let me erase my old marks. I see how many terms? 1, 2, 3, 4. So I see 4 terms, so I just call it a polynomial. The highest exponent, or the degree, is a 4. So that is called quartic. Right here. Q. I used the wrong word. There we go. Quartic. So you find how many terms it has, you find the highest degree, and then you have to pick the right word from this list up here. Let's take a look at, I apologize. I just realized, and I'll fix this on your notes, that should say 8-1 notes. That should not say 8-1 practice. Excuse me. So this should say 8-1 notes. I'll fix that on yours. So this one wants us to write the polynomial in standard form. So standard form means I need to find the term that has the highest exponent. So I see that the highest exponent is 2x squared. I'm going to write that first. Now I need to find the next highest exponent, which is this one, because it has a power of 1. So I need to write it next. I have to put it in order. Now I'm going to find the next highest exponent, which is technically this one because it has an exponent of 0. So I put a plus 1 behind it. That's how you do standard form. Let's take a look at the next one. So the highest exponent is this one, 7x3. So I have to write that first. The next highest exponent is this one. So it's a positive, so I'm going to do plus x squared. The next highest exponent is this one because it has an exponent of 1. So minus x. And last, I have this one that doesn't have a variable, so the exponent is technically 0, or the degree of that monomial, so I'd write plus 64 in the back. Let's do that 2 more times. So I'm going to grab my blue again. There's the highest exponent. I'm just going to do blue first. Boop, 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 boop. Now I'm going to write that down in my answer, x to the third, highest degree. Now I'm going to switch to red to find my next one. 5x squared is the next one. It has the next highest exponent, so positive or plus 5x squared. Now I'm going to move to green just to stay consistent. I have this variable with an exponent of 1, so minus x. And then last but certainly not least, in purple, I have my constant. That the variable on it would be at 0 power because it has no variable, so it would be a power of 0 on there. There you go. Now for the next one. Highest exponent is this term here. Make sure you include the sign. So bring over a negative x to the third. Working my way down on the exponents, I have this one, which has an exponent of 1. Making my way down, I have this constant of 24. So I'd write it next. Now the next one, we have to be kind of careful because there's double variables, okay? So we're going to focus on A. My focus will be on A. Okay, alphabetically A comes first. So this one is going to be first because A has a power of 3. I'm focusing on A. So I'm going to write focus on A. Then this one's actually going to be next because A has a power of 2. So I'm just going to write 1, 2. The next one I'm going to do is this one because A has a power of 1. I'm completely ignoring B. That would make this one come last because it has absolutely no A's in it. So we have to be careful on these double variable ones. You focus on the first one that would come alphabetically. So this one I would do A to the third. Then I would do this giant term plus 5A squared B squared. And remember, my focus is on what variable? A. I don't focus on B because you have to focus on alphabetical things. The next one is this one, 2. So again, we're not focusing on B. We're focusing on A, like that. We're not focusing on B. We're carrying it down, but now we're going to focus on it. And then last is the one that doesn't have any A's. Well, technically A to the 0 power. That one will go last. We're going to repeat that process on the last problem. How many things? I have 4 things again. So 1, 2, 3, and 4. Let's take a look and see which ones should fit those. So X and Y. I'm going to focus on X because that comes first in the alphabet. So find the one that has the biggest X exponent. That's this one. That's the first one. X has an exponent of 3. So I can highlight that in blue. Now for red. Again, focus on x, please. Let's see, no x. Here it is. This one has an x to the 2 power, so I'm going to focus on that one next. That's number 2. Let's find number 3. Let's see. Since I don't have any other x's, I have to ask like which one goes first. And to be honest with you, in Algebra 1, I'm fine with you putting either one first. I'm going to put this one next because it has a variable. So I'll call that one number 3, and I'll count this one as number 4. Now, if one of those had an x, I would put that one next. If one of those had an x, I would have put that one next, but none of them had an x. So I have number 1 is negative x3. Notice how I keep the sign. Number 2 is negative 7x squared y squared. Number 3 is positive 5y cubed. And number 4 is positive 13. Now I have 10 minutes to teach you how to add and subtract polynomials. So I don't think I'll be able to get to all of these in 10 minutes. I believe I should be able to do this lesson in 25 minutes, which is what my goal was. So I'm going to pick a couple of adding ones, and I'm going to pick a couple of subtracting ones. The main idea is that you need to, hopefully you already know how to do this, combine like terms. And if you don't, that's why it's my time to shine here. You ready? We're going to start with the first one. Excuse me, I'm so sorry. The first polynomial is a quadratic, because of this term, trinomial. Sorry, guys. And the second polynomial is also a quadratic trinomial. I'm going to tell you that the plus sign simply means you add one to the other. You don't have to change anything. So I'm going to write my negative 2x squared, and then behind it, I'm going to write my positive 3x squared. So I'm going to put them together. And then behind that, I'm going to write my regular x. So I'm going to write my 18x next because it's a single x. And then my minus 8x behind that. And then I'm going to write the 15 because it doesn't have an x, and the minus 10 with it. Now we will combine our like terms. Negative 2 plus 3 is positive 1 with an x squared. And I was going to grab my calculator before I started, but there it is. So I would do negative 2 plus 3, and that's how I got, try again, Amy. Negative 2 plus 3, that's how I got a positive 1. Shrink this down so I can have more of my screen to work with. All right, and let's see, now I'm going to have a positive 18, take away an 8. So I'm going to have a positive 10x when I put these two together. And last, I have to do 15 minus 10, and that's going to give me a positive 5 when I put those together. So I wrote them in order, and then I took their coefficients and added their coefficients together. Let's do another adding one. Now let's do an adding one that's a little different. This one's very, very, very similar to the one up above. So I'm going to move down to this one, number 5 right now. So I have my first polynomial, which is a cubic trinomial, and I have my second polynomial, which is a quadratic binomial. I'm going to start with the high, and this is a plus problem. I'm going to start with the highest one. That's going to be x to the third. So I see, let me actually maybe color code this a little different for you. Let's see if you guys like that. So x to the third is the only x to the third I see. Actually, how did we do that up above? Didn't we do that in blue? Didn't we do our biggest one in blue? So I'll stay consistent. I think we did blue, then red, then green. Now, the next one I see is x to the second. Well, this one also has an x to the second. So I'm going to write those beside each other. 2x to the second and 3x to the second. So those were both x to the second. So that's why I wrote them beside each other. And now let's see. I have a minus 4 and an add 6. So those were like terms because they don't have any x's to them. So I put those beside each other. Now this blue x to the third is just x to the third. This right here, I would do, if you need your calculator, you would do 2 plus 3. And that would be a positive 5x squared. And then this would be a negative 4 add a 6. And I would get a positive 2. There's no more like terms. Like They're like all the x squareds are together. Some kids, hey, let's just talk about this for a moment. I've seen in the past where kids think these can get put together and become something like x to the fifth. But that's not what we do. Those aren't like terms because they don't have the same exponent. So I've done a few adding ones. Is there a different one? Trying to find, I want to make sure I touch on everything and I only want to go to 115. The last adding one I feel like I'm going to do is number 16. Okay? It's not like the other ones. At least I don't think it is. Or should I do one with a double variable? That one is actually just like the last one I did. You know what? Let's do number 12 because number 12 has an x and a y. So I am going to, in blue, I'm going to highlight this 3x and I'm going to highlight this 2x because they both have an x to the power of 1. So I'm going to do 3x add a positive 2x. The next thing I'm going to do is I'm going to highlight this minus 6y and this positive 6y. Those are like terms because they both have the same variable with the same exponent. Now what I need to do is add 3 and 2, and I'll get a 5 with an x because 3 plus 2 is 5. And then I need to do negative 6 plus, ooh, does anybody know what's hiding in front of that 1y? There's a 1 there. So I would have to do negative 6 plus 1, and I get negative 5. So I'm going to do negative 5y. So hopefully you can see how the red became the red, and you can see how the blue became the blue, combining like terms. All right, guys, I have about 5 more minutes because I need to talk about subtraction. So let's go up here. This will be a good subtraction one for us to do. Number 2, I'm going to do a subtraction problem. I'm going to make a really big deal about subtraction problems because these are the ones that tend to give kids the biggest fits, even all the way up into calculus, honestly. This negative needs to be distributed like that. So this is really a minus 10x. It's really a minus 3x squared. And it's really a minus 2 because it's like you're distributing a negative 1. So now that I've done that, I need you to focus on these items. Let me highlight them in black. Those are the items you'll focus on when we start going through. So the biggest exponent I see is an x squared. So that one and that one need to be written together. 6x squared, take away 3x squared. The next biggest exponent I see is an exponent of 1. So those two should be written next to each other. The last thing I see is my regular constant with no variable of a minus 2. So it is my hope that you can see the minus 2 goes in the back, the x squares go in the front, and the regular x's go in the middle. Remember though, with the negative, I had to distribute it first. If you were to use the previous stuff that before the distribution, you would have done it wrong. So this is 3x squared, this is take away 3x, and take away 2. 6 minus 3 is 3, 7 plus negative 10 is negative 3, and then the negative 2. Let's try to find another subtraction one that would be really good to do. Maybe even number 8 would be a simple one, but yet let's make sure we're good. So the highest one I see is x to the power of 1, and those match. So I'm going to do 6x, take away 6x. I'm just rearranging because addition is commutative. And then that 4 is going to be next. So there's nothing like, there's no squares to deal with, so just that minus 4 in the back. So, 6 take away 6 is 0x, right? So we just don't write it. So my only thing I have left is a big fat negative 4. Another one. Let's find one. This one, find the difference. That'll be a good one. So find the difference. So that means you need to start with this one and you need to subtract this one. All right, so I am going to, since this is the one that I'm subtracting, I need to distribute my negative in. So I need to make it a negative 4x squared. I will make it a positive 2x, and I will make it a negative 3. Now it's time for me to find my highest exponent. Well, there's this 6x squared, and there's this negative 4x squared. I'll write those down right here. Now I need to find my next highest exponent, which is just a regular old x here and here. So I need to do positive 2x and positive 3x. And last, I need to find my constants of -3 and -5. And now I need to combine my like terms. So let's see, the blue ones. Let's finish strong. There's going to be 2x squared. 6 take away 4 is 2x squared. These make 5x squared. 2 plus 3. And last, use the calculator if you're not sure, please. -3 take away 5 is -8. So you can see the green became a -8, the red became a +5, and the blue became a 2x squared. So big ticket item that kids tend to miss is with subtraction, you need to distribute the negative and then combine. And that was a big lesson in about 25 minutes. Good job.